Okay, now when during this initial inspection, you find artifacts or some bad channels. How do you deal with it? One way of dealing with it is suppose you are seeing that this channel O1, which you see here, O1 is an artifact. It is not artifactual here, but just suppose that it is an artifactual channel. Then you may just right click over the channel and you can define that channel as a bad channel. If it is bad throughout. If it is not bad throughout, and then you also see that it is just bringing up some kinds of what you call artifacts, then you may want to interpolate that channel alone. In that case, you can just click on the interpolate this channel, and that channel is going to get interpolated. But when you interpolate it, you will see this channel in a purple color, labeled in a purple color, which will indicate or will show you that channel has been interpolated. Also, when you interpolate it, you need to make sure that this is not it is not at the bottom of this chain of the electrodes. Because if it is at the bottom, the problem is that it might only take some of the neighboring electrodes information. So it is better to take the maximum information around all the channels. And yeah, please be careful when you do that, when you're doing at the rim of a chain. Next, if you want to make this channel as a bad channel, define this channel as a bad, and it gets a grayed out, indicating that this channel has been a bad channel. So this is neither bad nor has an artifact. So I just want to remove it and then make it as it is. Next is we need to go to the certain time. Let us go to the certain time which I showed you sometime earlier. You can click go to. And you can use and you can choose the time. Let us go to the time 4 minutes and 28 seconds, because you might see something there. So here we see some kind of activity which is over here, and based on the frequency and the pattern, it looks like a muscle artifact. It is a muscle artifact. So now suppose you want to, you're studying the data based on the what you call frequency and activity. You know that it is an artifact, and you don't want to include this section in your processing. Then you can just left click that section and then keep your cursor in the yellow region, right click it, and you can define as artifact. When you do that, you get these brackets at the bottom. You see here the brackets at the bottom saying that A1, this is artifact 1. Now suppose there is another activity which is over here. You can click that and then you can label that as an artifact 2. Define it as an artifact, you get it as artifact 2. So depending on the number of artifacts, you can just click and mark it. Now, since we don't have an artifact over here, I want to delete this. So what I'm going to do is I'm going to right click over here and choose delete. So it's asking whether you want to really delete this. Yes. Give OK, and then it gets deleted. So that's it. So this region this portion will be removed from the further processing so that you can get to work with artifact free data. Next is one thing I wanted to add is show you is how you can add comments and markers to the data. Suppose you wanted to add a certain comment at this point. You can just right click over here and you can comment it as artifact in the tag that comes. Yeah, and now if you want, you can go to this event log. Some reason I don't see this. Okay. Okay. Now, if you have these comments and events already embedded in the data, it should be available. Next, I want to take you to another point. Let us go to that point. Go to time. Let's go to 5 minutes and 49 seconds. 5 minutes and 14 seconds. We go there. And here we see eye blinks. Here, just double click on the peak. You get 6 different views of this, of the field, electric field distribution. Now, what I see here is a frontal positivity and a posterior negativity. You see here. Now, why do I get this? So you see our eyes, the cornea and the retina is polarized basically. The cornea is positively, pulled. At the same time, the retina is negatively biased. So when we close the eyes, the eyeball just rotates backwards, and that is causing these frontal electrodes to be relatively more positive than the other regions. So in electrophysiology, the positivity means going downwards. It is the opposite of the other convention, where the positive is up and the negative is down. With electrophysiology, normally the positive graph is downwards and the negative graph goes upwards. So that is why you see a downward deflection, which indicates the eyes has been closed, during which the eyeball, the cornea has moved up and causing the frontal electrodes to have a positive polarity. Okay, next, what I wanted to show is this map, which you see here on the right side when double clicked, gives you the 6 different angles of viewing the same activity at the same time. There are multiple ways to see this. You can just, if you want to see an increased intensity version of this, you can just use this plus button over the right side, or you can also use the up arrow or down arrow on your keyboard, and you should be able to change and see it clearly. Next, what I wanted to show you is in this page. So this is the mapping region. You can double click on this and then you will get this one. And similarly, you can also use the standard view, during which you can see multiple ways of looking at the same data based on time. So this view is really helpful to see how the propagation, or else what happens just before or after your cursor point. So this is so here you have the 0th point. So this shows you what happens before 5 milliseconds, before 10 milliseconds, before 15 milliseconds, up to 85 milliseconds back in time, also forward in time. What happens? How does the electric field evolve or change during this period? Let me just minimize this and close this. So one more thing I wanted to show you was, okay, now suppose you have a high density data, 256 channel data. Here, then you can use, our eyes are not adapted to see all those 256 channels, or 128 even for that matter, will be too big to see in one shot. So we have this option wherein you can click this scalp button on the right side, and you can use, you can choose to see the first quarters of the total, second quarter, third quarter, fourth quarter, or first half or second half. So depending on the way how you like to see the data. Let me just, you can also use these bars over here to see the groups or the channel sets, which will be helpful in really understanding what is the data quality. Of course, in this case, it is not that useful because we already have a limited number of channels. We have only 31 channels, including the reference. But this will be a very useful when you are using a high density EEG data, or when you are using, or when you want to analyze the magnetoencephalography data, which has 306 millimeter, or else 250. I don't know the other number. So it should be typically 306 if it's an electrocyst. So that said, let us go to the montages. So here, so typically when I go to the customer sites, or when I meet my clients, the first question what they ask is, what is this minus F and this and this plus F plus on the ribbon, first buttons minus F. So when I have multiple files which has been loaded, using this minus F and F plus, I will be able to switch between these files. So in this case, I just have only one file opened. At the bottom, you can see I have just opened one file, and that is why I'll not be able to switch between the files. But later on, I will show you when we have more than one file, we'll be able to switch between the files by just using these buttons. We also have many different buttons, and my colleagues during their talks will explain each one of them, how they are used and why they are used and when they should be used for ease of work. But for now, I want to leave it there, and let us go to montages and see how we can make use of the montage system. So here, this is the RSA, recorded montage. So you have this original recording when it was recorded, with which you can also use this double banana, which is a classical recording montage. And all these are based on the original recordings. But we will see that CZ is flat, as mentioned earlier, because that is the reference electrode. Now let's go to another montage. This is the virtual montage, in which, so by default, this virtual is a virtual triple banana, which comes virtual triple banana. So which also has few more extra channels, or else montage channels has been included into the montage. So if you know the what you call classical double banana, you will know only there are a certain number of electrodes included. But with this triple banana, you have more electrodes which have been included. So these virtual electrodes are the channels has been how do you say that? It has been virtually created to project channels, activities in those channels. Now, if you go to this reference free, you can see that there is 27 channels in the reference free. You have these virtual sources as well as source montages. And let us first see what is the virtual montage. In order to understand it more, let us click on this EDM, Edit Montage button over here. So clicking that should show you what is how the electrodes are placed over the scalp. So these are the standard locations, standard 27 electrode locations in which the electrodes have been placed. Now, what happens with this is that with this montage, you can see one important factor, which is the CZ channel, which we saw earlier to be flat, is not flat anymore. It shows some small activity there. Earlier it was flat because all channels were referenced to CZ. But with this montage, virtual reference-free montage, we see that CZ, there is some activity going on. Now, how do we get that? It is because when you choose this montage, let me click on EDM again. So when you click on each channel here, you can see which channel it shows. So how you're able to see that activity in that CZ also is because here the surface integral, all the activity over each channel has been integrated, and being all the activity when you sum it up, the integral should be 0. And then that is being a reference to each channel. So each channel should have some activity which is slightly above from the integral zero activity. Harald, please do correct me if I say something wrong here.
Oh, sorry, I was just busy writing in the chat.
Oh, sorry.
So
I
what are
was
you
saying
saying?
that, yeah, sorry. I was saying that this with this reference-free electrode system, the montage. So then what we are showing actually is the zero integral reference with each of the electrodes.
Yeah,
Okay.
certainly
Okay.
correct. Yeah.
Okay, great. Thank you. So yes, so what we see here is that is the reason why we see an activity still going on in the CZ channel. So this is nice, cool. So that the main advantage of using such a system is that you don't get biased with the reference channel activity. Suppose in most EEG labs, the reference channel would be placed somewhere over the, close to FZ and FPZ channels. But when that is placed there, if there is a lot of what you call eye movements or else or some other activity, that activity in the reference channel will be reflected in all other channels. Or else, for some reason, if the reference channel has been moved, or else or else is it not, if it is not sticking or staying in the right place for some reason, movement or something like that, in that case, you can use this reference free in which you can find activities because of the total surface integral zero, which was mentioned earlier.